going to go over a couple of the things that we did on Wednesday. We left that we were naming some compounds and we were doing something called what's called Lewis structures and having things balanced as groups of 8 of the octet rule. We'll go over a couple of different names of things. We'll go from the book so you can learn from some of that. You'll be using the book next semester when it starts up. So let's do the formulas for, if you have the words iron, 3 nitrate. Okay. Now remember, iron is a transitional metal. If you have the ending ATE, you know that's a polyatomic ion usually. Okay. If it was just nitrogen, it'd be nitride. IDE is your ending for the second element in the compound name. It might be one, if it's not IDE, it's one from the polyatomic ion. If it's not an element, it's a polyatomic ion. I don't think we talked about that last time, but polyatomic ions, here's a list of your common ones. Okay. And again, you can see nitride, nitrate, it'd be nitride if it was just nitrogen. Nitrate is NO3 with a -1 charge. Nitrite is NO2 with a -1 charge. And you have different ones, phosphate, PO4 3-, phosphite, PO3 3-, acetate ion, cyanide. That's one of the exceptions. There's always exceptions in chemistry. Cyanide and hydroxide have IDE, but they're not ions. There is no hydroxide ion. So hydroxide is OH-. Cyanide is CN-. All the other ones are, a couple others like peroxide, things like that have IDEs, but most are ATE and ITE, as you can distinguish them. Okay? There's only one positively charged common to polyatomic ion, and that's ammonium. Ammonium is NH4 with a positive charge. All the other ones are negative charges. So when you're naming compounds, you have to realize the first step is to determine whether it's covalent or ionic. Remember, covalent is sharing electrons. You have to name the subscripts. Okay. Ionic means they're balanced by charges. When you have ions, they're ionic. So all the polyatomic ions are given ionic bonds. We're going to match the charges. Okay. So let's go back to what we had. So iron is Fe, and it's a 3+ charge because it tells you this is a 3+ oxidation state. And nitrate is NO3 -1. So to balance this neutrally, you have to have Fe, NO3 3 times. Remember the crisscross rule? You take the net 1 over here and the 3 over here. So the empirical formula, or the formula for the compound, the chemical nomenclature is FeNO3 3 times. So just to understand what the parentheses mean, it means there's 3 NO3 groups. So in this compound, you have 1 atom of iron, you have nitrogen, you have 3 atoms of nitrogen, and oxygen, you have 9 atoms of oxygen. Because it's NO3 3 times. Okay. Let's just start naming some other compounds here. I'll give you some examples. Let's do ammonium phosphide. Ammonium phosphide, IDE ending. So it's phosphate. And phosphate and phosphite are PO4 3- and PO3 3-. Okay. So ammonium is NH4, and that has a +1 charge. Phosphite is phosphorus, and that has a -3 charge. Remember how we got those charges? Ammonium is a polyatomic ion. Phosphite is the element. Go back to your periodic table. Remember, these were +1, +2, +3, and this column here is neutral. That's where carbon is. Okay. So everything in the first column is +1, second column is +2, third column is +3. And then this is -3, -2, -1. So look at phosphate. Phosphate's right here. It's in the -3 column. So that's what the charge is, -3. And the noble gases have a 0 charge, and all your transitional metals here vary. They can have different charges depending on what they are. with the exception of zinc, cadmium, and silver. Silver is always +1, zinc and cadmium is always +2. Those are the three exceptions to the transitional metals of varying charges. All right. So that's where the 3 came from. So it would be NH4 as a group 3 times and phosphorus. That gives you a +3 and a -3. That cancels out. So this would have nitrogens. It would have 3 atoms of nitrogen. It would have hydrogen. It would have 12 atoms of hydrogen. And phosphorus would have 1 atom of phosphorus. Because we NH4 3 times and then a phosphorus to balance it. Okay. Let's try another one. Lithium chloride. IDE ending is from the element chlorine. So lithium is Li, chlorine is Cl. Lithium is +1, chlorine is -1. They balance. So lithium chloride would be LiCl. Let's do one more. Let's do sodium cyanide. Sodium. Cyanide. Cyanide, you know, is a polyatomic ion. Sodium is Na. Cyanide is C, and Na is +1. Cyanide is -1. They balance. Okay, so that's how to go from English to chemistry. Now let's go from chemistry to English. Do the exact opposite. Let's take some AgOH. Ag is silver. OH is hydroxide ion. So that's silver hydroxide. Ag is +1, OH is -1. Okay. Remember, you don't have to name any of the substrates if it's ionic. Let's find another one. Let's do tin 2 chloride. Wait, I was going the other way around, wasn't it? Back that up. Let's do SnCl4. Okay, let's put that compound into the English format. So Sn is tin. Tin is a transitional metal. So we have to have a Roman numeral. And then we have our last one, our ending one as chloride or non-metal, IDE ending. So we have to tell the oxidation state of tin because we don't know. Since it's a transitional metal, we know that has to balance though. Chlorine is -1 and there's 4 of them. So that gives you a total of -4. So tin has to have a charge of +4. Okay, so it would be, again, Roman numerals, tin 4 chloride. Now, where a lot of things get confused is when there's a subscript there. Say we had this compound. Hold on. There we go. That would be tin again. And it's a transition metal. You got to tell you what the oxidation state is. And then chloride. Now, chlorine, there's the -1 charge. So this is, and 4, so there's -4. So this again has to be +4. But there's 2 of them. So each one has to be 2. 2 times 2, or 2 plus 2. There's 2 of this one. 2 that one is 4. So 2 twice is 4. So that's +4. So when the subscript is here, that's tin 2 chloride. When there's no script, that's tin 4 chloride, because you have to balance the charges. Okay, let's do I already have that one. Cr2 SO4. How many times is that one? Cr2 SO4 3 times. Okay, so Cr is chromium. And it's a transitional metal, so you got to tell the charge, because otherwise you won't know it. And SO4 is a polyatomic ion sulfate. Okay. Sulfate has a -2 charge, and it's 3 times. So its total negative charge is -6. Okay. So -2 3 times is -6. So this side has to be a +6 total. And there's 2 of them. So each one has to be 3 to give you a total of 6. So it's chromium 3 sulfate. Let's do one more. Let's do iron Fe2O3. So it's iron and transitional metal and then oxide. Okay. Now most students are going to put a 2 in there because there's a 2 sitting right here. And they'd be wrong. Okay. Because you have to determine the charge by balancing it. Oxygen is -2, and it's 3 times. That gives you a total of -6. Iron has to be +6, and so it matches. And there's 2 of them. So each one has to be 3 to give you a total of 6. So that compound is iron 3 oxide. All right, so we kind of reviewed how we named compounds. Then let's go to, we got now drawing some Lewis structures, then we'll go on to some new stuff on chapters and go through that. All right, so you're talking about Lewis structures. And Lewis structures have to have 8 valence electrons, the octet rule. The one exception is hydrogen. Hydrogen is a duet rule because there's only one s orbital we talked about. You only have 2 electrons. Okay. So we put all the dots that represent our Lewis structure. Let's do CH4, methane gas. Carbon has 4 valence electrons. Hydrogen has 1 valence electron. And it shares them. So the Lewis structure is, remember, every line is a bond, and every line has 2 electrons. Okay. So let's go back to the beginning of Lewis structure. That's how Lewis structures work. So let's go to the periodic table. You always go to the periodic table. A lot of information in the periodic table. Valence electrons. Okay, we look at the periodic table. We know this column, 1A, has 1 valence electron. Valence electron just means your outer electron. That's what determines all chemical reactivity. Column 2 has 2 valence electrons. Column 3 has 3, 4, 5, 6, 7, and 8. Okay? So anything in those columns will have that number of valence electrons. So carbon has 4, silicon has 6, bromine has 7, sodium has 1, barium has 2. Okay? The transition metal is barium. So that's how we're getting these numbers for valence electrons. Now, let's take a structure like hydrogen cyanide, HCN. In drawing Lewis structures, your first step is to count your valence electrons. Always do that first. So hydrogen has 1, carbon has 4, nitrogen has 5. So at the end of our Lewis structure, when we're finished, we have to account for 10 electrons. We have to have that many. So let's put it together. Let's put hydrogen, connect to carbon, connect to nitrogen. And let's fill in the dots. Remember, hydrogen can only have 2. So hydrogen has 2 with the bond around it. Carbon would have to have 8. Nitrogen would have to have 8. So we put all the dots around it. Every element has 8 except hydrogen, which has 2. So count your electrons. Remember, there's 2 in every bond. So of the non-bonding pairs, we'll start right here. We got 1, 2, 3, 4, 6, 8. We have 10 non-bonding pairs. And then we have 10, 12. We have a total of 14 electrons there because there's 2 in each bond. 14 does not equal 10. So what we have to do is make a double bond or make a multiple bond. And you can't do it to hydrogen because hydrogen can only have 2 electrons. So make a double bond right here. And then we have 2 electrons here down there. That gives us 8 around each one. Remember, there's 2 in every bond. So around carbon, there's 2, 4, 6, 8. Around nitrogen, there's 2, 4, 6, 8. We count your electrons. We have 2, 4, 6, 8, 10. We have 12. Again, 12 does not equal 10. So make another bond. And again, you can't make a multiple bond to hydrogen because it is the duet rule. Now everything has 8. Carbon has 8, nitrogen has 8, hydrogen has 2. Now count your electrons. We have 2, 4, 6, 8. We have 10. And 10 does equal 10. So this is the correct structure. That's how you do those structures. You determine the number of valence electrons, you put them together, and you make everything have 8, except for hydrogen to have 2. You can see cyanide is a triple bonded compound, very strong bond between them. Right, let's think of another one here. We did carbon dioxide, we did water, H2O. Hydrogen has 1, and there's 2 of them, so there's 2 valence electrons. Oxygen has 6. So you have to make a structure that has 8 valence electrons. Again, oxygen has to go in the center because hydrogen is what we call terminal. Once you have a hydrogen bond, it ends. So put a connector there, put our dots in, make oxygen have 8. Now count them, 2, 4, 6, 8. And that's equal. That's the Lewis structure for water. We have 2 non-bonding electron pairs on the oxygen atom. That's going to be very important in dealing with hydrogen bonding, we're going to talk about a little bit later. That gives it its structure, and gives it its shape. So we know from that configuration, this is a bent or angular molecule. And we'll get into that in a little bit. Over here. Let's do acetic acid. Acetic acid is CH3. Okay. CH3, COOH. Again, carbon has 4, and there's 2. Carbon has 4, so there's 2 of them. So that gives you 8. Hydrogen has 1, and there's 4 of them. That gives you 4. Oxygen has 6, and there's 2 of them. That gives you 12. Okay, so that gives you 24 valence electrons you have to account for. So you have carbon, bonded to hydrogen, bonded to carbon. And there's an oxygen, and a hydrogen. So then we just kind of put lines between everything. Now make everything have 8, except for hydrogen. So we make oxygen have 8. The oxygen have 8, and carbon have 8. And everything else has 8. So carbon has 8. First carbon has 8, second carbon has 8. Oxygens both have 8, and hydrogens each have 2. That's a hydrogen. Count your electrons. In the bonds, we have 2, 4, 6, 8, 10, 12, 14, and 16, 18, 20, 22, 24, 26. We have a total of 26. It doesn't work. Okay. So make a double bond. You can't make one on hydrogen. Okay. So make one on the carbon going up. Carbon bonds to hydrogen, bonded to carbon. Put your double bond right there, then O and an H. Everything have 8. I think that everything has 8 there. Yep. Then count it. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 24. And that's your Lewis structure for acetic acid, which is vinegar. Let's do one more. Let's do, this gives you an idea how to do them. Carbon dioxide. Carbon has 4, oxygen has 6, times 2 is 12. You have to have 16 valence electrons. So carbon goes in the center, oxygen, make everything have 8. Okay. Now everything has 8 around them. So count them, 2, 4, 6, 8, 10, 12, 14, 16, 18, we have 20. So we have too many. So make a multiple bond. And then make everything have 8 again. Okay, everything has 8 electrons, so count. 2, 4, 6, 8, 10, 12, 14, 16, 18. Still only get to 16. Make a second double bond. Put it on the other side also. Now everything has 8 again. 2, 4, 6, 8, 10, 12, 14, 16. And you have 16 electrons. That's just a basic introduction to Lewis structures. You get a much deeper review we have to take the class. This shows how to count valence electrons and how to do that with it. All right, let's go into chemical equations. Most students have trouble balancing equations because of the math involved in it. Okay. Balancing a chemical equation, we'll do that today, then we'll just call it quits, give you guys a good weekend. But balancing a chemical equation goes by the conservation of mass. Okay? This is for chemical reactions. In a chemical reaction, mass is conserved. In other words, if you had, okay, if we react hydrogen plus oxygen goes to H2O. If this was 5 pounds and this was 5 pounds, this would be 10 pounds. Okay? The mass on one side has to equal the mass on the other side. You cannot create or destroy mass in a chemical reaction. You can destroy mass in a nuclear reaction. That's what gives you all your power. Okay, but chemical reactions, we cannot destroy mass. So the mass has to be the same. The same number of elements must be on the left side. The left side are called reactants. And the right side is called products, what you produce. Okay. The same number of elements has to be on both sides of the equation. Okay. And you can never, ever, ever touch what's called subscripts. You can never touch this number, or this number. All you can do is put a number in front of each one to balance it. And that number will apply to the entire molecule. So let's write this out here. Let's write H2 plus O2 goes to H2O. Now, how many hydrogens on the left side? I have 2, right? How many hydrogens on the right side? I have 2. So that balances. Okay. Oxygen, I have 2 on the left. I have 1 on the right. So I have to make that say 2 also. So I have to put a 2, and the only place I can put these numbers are in front here. So I have to put a 2 there. Now my oxygen is balanced, but now my hydrogens have changed. On the right side, I have 2 H2s, so I have 4 hydrogen atoms. So now I go to the left side, I gotta make that say 4. How do I make that say 4? I put a 2 in front of that one. That gives me 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. Because this number here, this coefficient, applies to all this here, applies to everything that's out of the compound. I've got 2 of those. Another way to look at it is I have H2O. That's what H2O is, right? I have 2 of these molecules. So look at this. We have 4 hydrogens and we have 2 oxygens. But all equations, all chemical equations have to be balanced or they don't mean anything. They have no value if they're not balanced. It just tells you what we're going to do. We're going to do something called moles. And moles are how we balance a chemical equation. This tells you there's 2 moles of hydrogen are going to combine with 1 mole of oxygen to produce 2 moles of water. If there's nothing in front of it, it just means that it's a number 1. Okay. So let's do some simple equations here. Let's do combustion reactions. Combustion means burning in the presence of oxygen. So hydrocarbons are compounds that have carbon and hydrogen, like methane gas we talked about. We have methane gas plus oxygen, which means we burn in oxygen. And hydrocarbons produce carbon dioxide plus water. And make it a little bit better. Okay, that's the reaction. That's to say for we do octane. That's octane, butane from your cigarette lighters, octane from your car, propane from your gas grills. All those react with oxygen and produce CO2 and water. Now to balance them, there's a trick. Always, if there's an element by itself, and there is an element by itself, we have oxygen, which is just has oxygen. All the other ones have a combination of elements in them. If it's by itself, leave it to the end. That just makes it so much easier to balance. All right. So carbons on the left, we have 1. Carbons on the right, we have 1. That's balanced. Hydrogens. Hydrogens on the left, we have 4. Hydrogens on the right, we have 2. So what do we put in front of that other hydrogen to make it say 4? What number times 2 equals 4? So that has to be a 2. Okay. Now we've got 4 hydrogens on the right side. Now oxygens. We have 2 oxygens on the left. We have how many on the right? We have 1, 2, we have 4. We have 2 here. We have 2 here. So that gives us 4 oxygens. So how to make that say 4? I put a 2 in front of it. And that's our balanced term equation. So what this says is that 1 mole of methane is going to react with 2 moles of oxygen to give you 1 mole of CO2 and 2 moles of water. Now this says 4. And we're balanced. Okay, let's do octane. Octane is burned in your vehicles. It's C8H18. And that's octane. Reacts with oxygen to give you, again, CO2 plus water. And what I say about ones by themselves, the oxygen, you leave it till the end. Okay. So we have 8 carbons on the left. We make 8 carbons on the right. We have 18 hydrogens on the left. We make this say 18 on the right. Now, how many oxygens do we have on the right-hand side? We have 8 times 2, which is 16 plus 9. So we have 25 oxygens on the right side. How to make the left side say 25? I'll show you another trick. When you're multiplying by 2, okay, we can say 25 over 2. Oops, what's that? 25 over 2 times 2, because there's a 2 right here, gives you 25. Now, the fraction is just there temporarily. We're going to get rid of it in just a second. I know you don't like fractions, but it's just a way of equalizing the numbers. Because 25 over 2 times 2 is 25. That's what makes sense. Now, we can't leave a fraction in because you can't have fractions of an atom. So multiply everything by 2. So we get 2 C8H18 plus 25. Multiply that by 2 because it came out to 25. All right, 25 oxygens. And then 8 times 2 is 16. 9 times 2 is 18. And there's your balanced equation for octane as you burn your car engine. 2 moles of octane plus 25 moles of oxygen is going to produce 16 moles of carbon dioxide and 18 moles of water. If you want to double check it, carbon has 16, carbon has 16. Hydrogen, 36, 18 times 2. Hydrogen has 36. Oxygen, there's 50, 25 times 2, and then there's 16 times 2 is 34, plus 18, What did I do wrong? Can't be 30. It can't be 36. 36 hydrogen. Yeah. 36 hydrogen. And then oxygen. What did I do? 16 times 2. That's what I did wrong. 16 times 2 is 32, not 34. Sorry. 16 times 2 is 32 and 18. 32 and 18 gives you 50. So everything balances. As long as you do simple math right, it balances. Okay. A couple more equations and we will call it quits for the night tonight. So you get good practice balancing the equation here. Let's do a single displacement and double displacement. Let's do potassium plus copper 2 chloride goes to copper plus potassium chloride. Okay, so let's leave potassium till the end, leave copper to the end. You have 2 chlorines on the left. How do you make it say 2? Put 2 chlorine, put a 2 here, and then put 2 potassiums, and put a 2 there. And we're balanced. So 2 potassium at moles reacts with 1 mole of copper 2 chloride to give you copper solid plus 2 moles of potassium chloride. And let's do another one. Let's do sodium, mix them up here. Na3PO4, sodium phosphate, reacts with barium chloride to give you sodium chloride and barium phosphate. Go for twice. Okay. Now remember, you can never, never, never touch this number, touch this number, touch this number, or touch this number. So those are determined by charges. That's how we balance our compound. You can never touch those numbers. Okay. And now we're going to balance things with polyatomic ions, balance them by groups. In other words, you see a PO4 group here, you see a PO4 group here. Just leave the PO4 group, don't do the phosphorus ions separately. Balance a group is a whole lot easier. So let me write it a little neater here. Oops, let me get back to our screen here. There you go. Na3PO4 plus barium chloride goes to sodium chloride plus barium phosphate. That's a 4. 2 times. All right. So let's look at, let's start with our phosphate groups, PO4. We have 2 PO4 groups on the right. We're going to have 1 on the left. So let's put a 2 here in front of, let me put a different color here. Let's put a 2 here in front of this. That gives us 2 PO4 groups. Now the PO4 groups are balanced. But that gives us 6 sodiums. So you put a 6 right here. That gives us 6 sodiums. And we have 3 bariums on the right. So we got to put a 3 here. That gives us 3 bariums. And then we have 6 chlorines on the left, 6 on the right. And I think that is balanced. Let's see, we have sodium, we have phosphate, we have barium, and we have chlorines. So sodium, we have 6. PO4s, we have 2. Bariums, we have 3. Chlorines, we have 6. That's on the left side. Counting those out. On the right side, we have sodium. We have 6. We have phosphate. We have 2. We have barium. We have 3. We have chlorine. We have 6. They all match. And there's your balanced chemical equation. Okay. I'll go over more of those and how we're going to use them because there's a lot of math involved with balanced. There's a lot of your. Once you have a jump hat, now we're going to use those curves to expand into being able to predict how much you're going to form of something. Like you're going to mix so much of this and so much of this, how much is going to be formed from balanced chemical equation. You have to start with a balanced chemical equation. You have to understand the math to balance these equations and then use that for other things. All right, So if there's any questions, review this. I'll put this online. The first 3 sessions are already online. You can pull them up on the Canvas. Okay. If you have any questions, email me. I'll be glad to go over there, give you more examples, make sure you understand everything. That's what I'm here for. You just have to understand the math and the processes involved to help you get through chemistry. All right. I shall see you guys have a great weekend, and we shall see everybody on Monday.